Thank you very much to the organisers for this opportunity to share with you some messages about Far-UVC. Because it's a 5-minute period, I'm actually only going to give one sort of important takeaway take-home message on Far-UVC, and I'll do that after presenting 4 different pieces of evidence. If you would like to learn in a bit more detail about Far-UVC, if you just do an internet search, there's lots of great articles and research out there, and most of them are open access as well, which is fantastic. So we've got 5 minutes, 4 pieces of evidence, and 1 take-home message. So let's start with what is Far-UVC. Well, it's high energy ultraviolet C light that can inactivate pathogens. And when it is filtered to remove longer wavelengths, it doesn't penetrate very far in human tissue. And because of that, it doesn't cause any immediate adverse effects on the body. And to our knowledge, so far that we've found out, there's no long-term adverse effects either. Now, the most common source of Far-UVC at the moment is the krypton chloride excimer lamp, but there are lots of different people working on alternative sources like LEDs. So what's the first piece of evidence? The first piece of evidence is that Far-UVC is very effective. This is from data that we published in Scientific Reports last year. And in our room-sized chamber, so it's a 32-meter cubed chamber, where there was a constant production of an aerosolized pathogen, Far-UVC lowered that pathogen load by 92%. And that's when there were 5 lamps in the room operating at 10% of their maximum intensity. Now, that would be an equivalent to an electrical consumption of just about 6 watts. And with just that 6 watts of electrical consumption, we got a 92% lowering, which was equivalent to 35 air changes per hour. Just to emphasize that, that's 35 equivalent air changes per hour for just 6 watts of electrical consumption. Second piece of evidence is that Far-UVC gives much higher equivalent air changes than most other technologies. And in this example that you can see here, you can see these high equivalent air change values at different mechanical ventilation rates within the chamber. And these are the types of numbers that really you don't see with other technologies. Now, I have to emphasize and be absolutely clear, I am not saying that Far-UVC is better than everything else. It is definitely part of the package, but it does need to be a part of the package. The third piece of evidence really is that with Far-UV, short-range inactivation is possible. It's not great. The situation does need to be optimized. So for example, in the image shown in the slide here, the lamp has to be directly between the 2 individuals. And in our studies in the chamber, we found that when our source and our collection were 2 meters apart, we got a 57% reduction when the lamp was on. So it is possible, but not necessarily the best. The fourth piece of evidence that I want to present really is that Far-UVC does produce ozone. There's no denying it, it's absolutely fundamental. But that ozone doesn't need to be an issue, because the ozone produced, or the amount of ozone produced, depends on the amount of Far-UVC that's being used. So on the left-hand side of the slide here, you can see that in the chamber, when we had 5 lamps at their maximum intensity, yes, there was absolutely an increase in the amount of ozone that we measured. So if we had a mechanical ventilation of 1.5 air changes per hour, we saw 50 parts per billion above background. But if the lamps were just operating at 10% of their maximum intensity, which is the graph on the right here, then there was no detectable ozone measured at all. And remember, 5 lamps at 10% intensity was 35 equivalent air changes per hour. Which really brings me to my one take-home message from this presentation, which is that our evidence is showing that you get very high inactivation without the measurable secondary chemistry. Now, I know that not everybody agrees with me, But where we disagree is not actually on the ozone, but on the efficacy of the lamps, because our experiments are showing better inactivation than some of the smaller laboratory experiments which have been undertaken to date. Now, what gives me confidence in bringing this to you today is that the results from our chamber are now starting to be supported by experiments carried out in the real world as well. So just to reiterate, my take-home message from this is that Far-UVC can produce high inactivation without inducing any significant secondary chemistry. Thank you very much.